Okay, so this is endocrine part 2. We're just going to do like a fast little run through of what feedback loops look like. And these aren't all of the examples. These are just some of the most common ones that you will see, because I just feel like a lot of you are going in the direction of something medical, and it's a good little intro to that. Okay, so remember that we have negative and positive feedback loops, and we're going to see a few examples of that. Something I want to touch on first is I want to talk about the difference between the nervous system signaling and the way that the endocrine system is going to signal. So in the nervous system, we know that signals are going to be sent by neurotransmitters. They're going to be sent really, really quickly and really, really precisely to the next cell. It's going to be like something similar to like a direct message email type situation from cell to cell. In the endocrine system, signals are going to be sent by hormones to many cells throughout the body. And with this, because it is going further and it is targeting a lot more cells, a lot more tissues, normally we're going to see a more delayed response, but we're also going to see a more prolonged response from that. So think about this like a public post on Facebook to many people, or something like that. So you're having that message received, but you're not having it received quite so quickly and precisely, right? Similar to neurotransmitters, hormones are only going to affect those target cells that have receptors for them. So if they lack the receptor, then they're also going to lack the effect, right? The nervous and the endocrine systems are going to work really, really closely together to maintain the homeostasis in the body. And we talked about this in the last lecture, but just to remember this concept, the hypothalamus in the brain is what is going to control the communication between these two systems, right? So when we're talking about the communication between the nervous and the endocrine systems, the hypothalamus is going to be the control center for all of that. I just gave you all a really simplified little diagram here that kind of summarizes everything that I just said. So you can see in our endocrine loops, you're going to have glands or gland cells secreting hormones into the bloodstream, and then they're going to be carried through the bloodstream to those target cells, where those hormone receptors are going to respond to the hormone, and it's going to be a little bit different in the nervous system. If you remember from our last chapter, we're going to have the neuron that is going to conduct those impulses. We're going to have neurotransmitters released into that synaptic cleft, and then we're going to have that postsynaptic cell that's going to respond to it. So the main takeaway here is that we are just talking about the difference between transferring that signal through a neuron versus through the bloodstream. Okay, so let's talk a little bit about different kinds of feedback loops. So hormone signaling and, how do I want to say this? Hormones are going to signal other hormones to have something happen. So sometimes we will have hormones signaling hormones that signal hormones that then cause an effect. We will have positive and negative feedback loops. So with a positive feedback loop, the signal is going to become stronger as the hormone signal grows. So the more we have that hormone signal, the more we are going to have the response to that signal. With negative feedback loops, these are going to become weaker as the hormone signals grow. So these do the opposite to maintain homeostasis. So examples of this is going to be like our hypothalamic pituitary adrenal axis, and we will talk a little bit about that, the hypothalamic pituitary thyroid axis, and the pancreas and glucose, which we talked about a lot in the previous lecture. We already talked about the pancreas and glucose, so I'm going to kind of fly through this one a little bit. We know that we have a stimulus, which is going to be eating something with sugar in it. This is going to cause blood glucose levels to rise. Then we're going to have the beta cells in the pancreas release insulin into the blood. The body cells are going to take up the glucose, and the liver is going to take up glucose and store it as glycogen. So we have a little branch off there. And then everything kind of comes back together when the blood glucose level declines, right? Because eventually over time that is going to decrease in our system. And so the opposite end of that is whenever our blood glucose level falls due to just time passing, the alpha cells in the pancreas are going to release glucagon. Glucagon is going to break down that glycogen that we stored in the liver and release it as glucose, and that glucose is going to enter the bloodstream again, and that is going to then bring that low level back up to the homeostasis that we're looking for. Okay, so here is another one that is super important, the hypothalamic pituitary adrenal axis. So this is going to be a combination of the nervous system and the endocrine system coordinating the fight or flight response. So we're going to have a stimulus here of something scary or stressful. And in response to this, we're going to get a signal from the nervous system that is going to tell the hypothalamus to release CRH. CRH stands for corticotropin releasing hormone. This is going to signal the anterior pituitary to release ACTH, which is going to signal the adrenal glands to release cortisol. Remember, I said sometimes we have a hormone that stimulates a hormone that stimulates a hormone that causes an effect. This is what I'm talking about here. So the cortisol is then going to signal the cells throughout the body to go into that fight or flight mode. Once the hypothalamus detects the cortisol in the blood, it is going to stop secreting that corticotropin releasing hormone and to kind of start to stop that fight or flight response. This is a negative feedback loop because the hormones are in the bloodstream. It's going to take longer to return to normal, so we want to get that shut down before there's too much. Hormones, just like anything else, you don't want to have too little or too much. You want to have exactly the amount that you need to cause the effect. So I put this just on a diagram. This is everything that I just said, but with images and everything mixed in there too, so that you can see the anatomical structures that all of these steps are passing through. We also have a hypothalamic pituitary adrenal axis kind of problem that can happen, where if you're in a constant state of stress or anxiety, you might signal the secretion of cortisol more often than you should, right? Cortisol can be kind of damaging to cells. So this is the physiological reason why constant stress is not good for you. Let's talk a little bit about the thyroid too, because this is a really important one that you will definitely see again. So this is another nervous and endocrine coordinating system that helps to control metabolism homeostasis. So the stimulus for this is going to be low levels of T3, T4 in the bloodstream. Remember, this is what is being produced by our thyroid. We talked about that in the last lecture. So the response to this is that there's going to be a signal from the nervous system that is going to tell the hypothalamus to secrete thyroid releasing hormone to the anterior pituitary. The anterior pituitary is then going to secrete thyroid stimulating hormone to signal the thyroid to release more of the thyroid hormones, which is this T3, T4, and this is going to affect the metabolism of a variety of cells in the body. So this is going to cause a change in our heart rate. This is going to change our body temperature. This is going to change our basal metabolic rate. We don't want too much thyroid hormone in the system, just like we don't want too little. So again, as we have a lot of that thyroid building up in the blood, this is going to signal the pituitary and the hypothalamus to stop secreting that hormone. Again, this is a negative feedback loop. That is all that I really have for you as far as just specific examples on this. There are way more examples of how the endocrine system maintains homeostasis in the body, but I'm not going to test you on all of those, and so I didn't want to overstress you with putting all of them in a lecture, but I did want to kind of just drive home how these processes work. And how multi-leveled they can be sometimes. This can be kind of a hard concept to get. I'm going to throw some extra resources into you guys' little notes and resources folder. I would definitely watch some of the videos and things on this, because this is one of those concepts that you might have to see it 3 or 4 times before it's going to stick. And as always, if you have any questions or need any help getting this information, I know it's spring break, but you still have my information. You can reach out to me. I will try to circle around and check it every so often. So yeah, reach out if you need anything.